My talk today is called Modernizing Ruby Systems with the Faster Rage Framework. And there are three things I wanted to talk about today. First, I will talk a bit about Rails. Most of us use Rails. I guess we love Rails. I definitely do. But today, I will specifically focus on things I consider problematic. Then, I'll talk a bit about the Rage framework. I'll talk about its features and some architectural traits. And finally, I'll tell you about my experience integrating Rage into two very different applications. And I'll share the results of comprehensive load testing of these applications. But before that, just a tiny bit of context. I've been in the industry for more than 12 years, worked with a range of technologies starting with C++ and ending with Kotlin. But throughout my career, one way or another, I've always worked with Ruby. Now, I work in a consultancy, which means I can work with many different companies and applications in a small amount of time. And one thing I noticed is that not only fewer and fewer companies decide to choose Ruby to build their products from the ground up, but even companies that already use Ruby choose to deprecate their Ruby apps instead of continuing to maintain them. Every decision has a reason behind it, right? And I was curious to understand what could be the reasons behind these decisions. I'll go into more details as I proceed, but a more general problem I see is Rails monopoly. One thing I like about other technologies is that there are many different frameworks. Frameworks that implement different ideas, pursue different goals, which are created by people with different views. In the Ruby world, though there are many different frameworks, Rails is essentially the framework. Whatever Rails core team adds to the framework quickly becomes the way to go. Whatever they choose to ignore comes to nothing. And because of that, the Ruby ecosystem is falling behind. And when I see how Rails and consequently Ruby decline in popularity year after year, I naturally ask myself, what's wrong? Like, clearly there's something wrong, right? But what is it? What are the reasons behind it? Well, I created the Rage framework in an attempt to answer these questions. So now let's talk a bit about issues with Rails. And for me, the most obvious one is performance. On this slide, I have the results of a simple benchmark of a Hello World test application. The column on the right represents a bare rack application. And while we don't usually use rack to create web applications, this number serves as a reference point. It shows how much of an overhead the framework of our choice actually adds. The column on the left represents a similar Rails application. There's no business logic, no database requests, no advanced Rails features used, even logging is disabled. Yet, our application becomes almost 40 times slower by just adding Rails to our stack. It's a good time now to pause and consider whether you think it can be justified. I think it can't. Now, performance is a controversial point, because there's an opinion that says framework performance doesn't matter. The bottleneck is always the database or the application logic, so why bother? I agree with this statement. It makes sense. Framework performance doesn't matter that much. Still, there are several things to discuss. And first of all, when it comes to Rails, the price we pay in terms of performance is just way too high. The thing about the number on the left is that this is the best performance we could possibly get. And it doesn't matter what we do. We could cache all our data in memory and never send a query to the database. We could write all our business logic in C, it wouldn't matter, as this is the limit Rails imposes. Do we have to introduce this much of an overhead for what in essence is a relatively simple DSL on top of rack? Does it have to be that slow? Okay, Roman, we got it. Rails is slow. Does it actually matter? I think it does, and one of the reasons for that is market demand. Fastify, which is highly focused on providing the least overhead, is one of the most popular Node.js frameworks. Fast API, which among other things is focused on high performance, is used by every fourth Python developer. With this, it just doesn't matter whether within performance is an important metric for a framework or not. There's a demand for high performance, low overhead technologies, and there's not much sense in ignoring this demand. Another issue I want to talk about is Rails full stack approach. Usually, this is considered one of key strengths and core features of Rails. In theory, you don't need anything except Rails. You can even write front end with it without a single line of JavaScript. Just run and generate a command, and you're up and running in no time. I think that such approach mostly makes sense in two cases: hobby projects or rather impressive articles titled "How to Build a Web App in 15 Minutes." When we are talking about professional web development, it's actually fine to spend more time setting up the project and defining the architecture. It's actually fine to use different tools for different tasks, and it often results in a more flexible approach. It's actually fine to split the back end and the front end, and I would even go as far as to say that's what we usually want to do. The front end is a belated issue here. If I had to choose one word to describe front-end solutions in Rails, I'd choose unreliable. There's something new with almost every Rails release. New features are always a very interesting and exciting thing to implement and work with. But on the other side of this excitement are companies. Companies that don't find this exciting. Companies that spend big amounts of money adopting every change. Companies that are just looking for a stable and reliable framework to build their products with. And I can't really call Rails stable. Between even minor versions, there are dozens of changes inside the frameworks. Every Rails upgrade takes lots of time, often introduces bugs, and sometimes even requires rewriting and refactoring. So my point is, the less we depend on Rails as a Swiss Army knife type of tool that does everything for us with its magic, the more stable and simple code base we will end up with. The last issue I want to briefly touch on is its ignorance of modern Ruby. The Ruby core team does a fantastic job improving the language, and I think it's a shame that some of their efforts are being ignored inside the community. For example, Raktas, an abstraction that provides true parallel execution without the burden of the global interpreter lock. Completely ignored. Fibers, another fantastic feature I'm going to be talking more about today. Essentially, it allows to pause Ruby code wrapped inside a fiber and then resume this code later. In theory, it allows to create Node.js type applications that do not block while waiting on I/O. Completely ignored. So with this, let's talk a bit about the Rage framework. So what is it? On this slide, I have two code snippets. The code snippet on the left is a regular Rails controller. It follows a usual pattern of using a before action to find some data. It implicitly halts the execution if the data is not found, and it renders JSON. The code snippet on the right is identical, and the only difference between the two is the parent class for our controller. By looking at it, you can understand that the controller on the right is actually built using the Rage framework. Hence, the first feature, Rails compatibility. The framework is designed to be a drop-in replacement for Rails in API mode, and it exposes the very same API that behaves in the very same way. Before actions, accessing parameters, using active record, everything works out of the box exactly the way you would expect it to work, with exactly the same code you would use in Rails. So that's the first feature. Another one, low overhead. While providing the exact same API as Rails, Rage has much less overhead. This is the same benchmark we looked at on the first slide, but with addition of rage. In this test, it performs almost 24 times faster than Rails. Another feature, fiber-based concurrency. Rage wraps every request in a separate fiber and implements a custom scheduler that pauses the fibers once they encounter blocking I/O, delegates waiting on the I/O to the operating system's kernel, and then resumes the fibers once the I/O is ready. The result? Let's say we have a controller that sends a request to another application and receives a response 1 second later. For Rails running in 5 threads, it will take roughly 25 seconds to complete 100 requests. For Rage, it will only take 1 second. The last feature I want to talk about is one of its architectural traits. The basis of Ruby web development is a standardized interface called drag. The idea is that there are multiple frameworks and there are multiple servers. And you are free to use any server to power your application as long as it implements the RAG interface. I don't think such approach makes sense, at least not anymore. We don't need multiple application servers. We only need one. And Rage introduces a tightly coupled architecture. It ships with its very own server, which is a part of the framework. It still uses RAG to be compatible with all the custom RAG middlewares. But we don't need to choose whether we want to use Puma or maybe Passenger is better these days. One of the benefits of such approach is flexibility. By being in control of our own server, we can now move some lower level code to the actual server level, or even break the RAG protocol while still remaining compatible with the custom RAG middlewares. Right, on to the exciting part. I'm going to share the results of integrating Rage into 2 very different applications. So let's look at the first one. This is an application you could probably call an IO-bound application. It makes database requests, uses Redis a lot, but most of the time it spends talking to other applications via HTTP and waiting for these applications to respond. Such a use case is the best case scenario for Rage. With the help of the fiber scheduler, Rage doesn't block while waiting for these applications to respond. And in theory, can be much more efficient than Rails. So what do the tests say? Here, I will share the results of a stress test, which was running at a close to peak load for 1 minute. So in 1 minute, our Rails application was able to process 1,100 requests with a P95 response time of 400 milliseconds. The same application with Rage integrated in 1 minute was able to process 9,000 requests with a P95 response time of 250 milliseconds. So not only we were able to process 8.5 times more requests in the same amount of time, our application was also much faster to respond. What this data actually means? Well, first of all, if we can now process 8.5 times more requests in the same amount of time, means we need 8.5 times fewer servers to process the same amount of requests our application is currently capable of processing. Another use case, traffic spikes. Imagine an influencer sharing a story about your application. And out of nowhere, you have hundreds of users trying to use it. Or a network glitch, after which your service receives several times more messages than usual. This data shows that with Rage, we can now process traffic spikes much more reliably. So let's look at another application. This one is very different. It doesn't make any HTTP calls. Instead, it only issues very fast database requests and spends most of the time inside the Ruby layer. Now, same as the first application was the best case scenario for Rage, this one is the worst case scenario. The amount of time the application spends waiting for the database to respond is almost negligible in comparison to the time it spends inside Ruby. And in theory, with this application, Rage should perform similar to Rails, because the bottleneck is somewhere inside the application, whether it's active record or notoriously slow active model serializers. So let's look at the tests. Same test, 80% of max load for 1 minute. While our Rails application was able to process 11,000 requests, the Rage application was able to process 30,000. So even in this case, we were able to process 2.5 times more requests while responding almost 100 milliseconds faster. This is possible thanks to Rage's connection pool. Rage has its own database connection pool implementation, and it can use it instead of the active records connection pool, effectively eliminating a big chunk of active record overhead. So let me sum up what I've talked about today. When talking about Rage, I happen to focus on performance a lot. That doesn't mean I see performance as a most important quality of a framework. And in fact, I see the fiber-based concurrency as the main feature of the framework. Yet a valid question is it actually relevant? There are not many high-load Ruby applications. So is it relevant? And that is indeed a valid question. If an application peaks at 100 requests per hour, Rage won't change much here, at least from the performance standpoint. But what if we think about non-Ruby companies? These companies, in fact, want to use Ruby, because Ruby is a great high-level technology that allows you to iterate really fast. It's a technology with a big and well-seasoned community. But they look at the Ruby ecosystem, they look at Rails, and what do they see? Performance is a concern. Maybe you'll need to scale, maybe not, who knows? But it's a risk not everyone is willing to take. Creating IO-bound applications is another concern. Is it not possible with Rails? Yeah, of course it's possible. But again, it's a risk not everyone is willing to take. The game of introducing new features and approaches simultaneously deprecating the old ones is another concern. And this is precisely what drives companies away from using Ruby. And I think that Rage could be a missing piece here, a technology that can do less, yet is more versatile. Performance is not a concern. And while low overhead is not a promise to developers that their applications are going to be fast, it's still important. It's how much of a leeway you have to write slow but maintainable code. It's how much of a load your application can handle before you actually have to think about scaling it. Library creators write performant code so that you don't have to. Creating IO-bound applications is also not a concern anymore. Thanks to Fibers, we can now process hundreds of requests simultaneously. Being an API-only framework, it has a narrow and well-defined scope, which means it's stable. And it's still the same Rails syntax probably close to 100% of Ruby web developers are familiar with. As you can see, there are many very exciting things going on in the Rage project. And if you, like me, love Ruby, want it to become more popular, if you want to improve and modernize the Ruby ecosystem, please join the community and please join the team. Thank you.